visually cool about it, so I sort of feel out of place, but you'll have to get over it. I'm going to talk a little bit about geoprocessing using the native types of the database. I don't know who all here is really the database stuff, but it sort of is the underlying piece in all of our applications. So when we're dealing with spatial data, we sort of have a toolbox, and especially when we're talking about processing it or doing things with the data, we're familiar with a lot of these, ARC objects, ARC map. We're going to simplify things, we're going to generalize using ARC tools, we're going to do all these things, but I'm going to throw out that there's a whole bunch of stuff you can do using the native functions in Oracle and SQL Server, and then you can expose those back through SDE to your spatial applications, whether they're ArcGIS server apps in the web or desktop applications or entirely non-spatial applications that are built on top of spatial data. So, what kind of problems is good for? It's good for things that are time-dependent or prone to error, repetitive tasks, things that are consistent, things that are programmable. So this is sort of the scripting model that we're going after. And so what do I mean by native spatial functions? There's built into any spatial database that has native spatial support are some of the basic things like crosses, difference, contains, distance. What's the distance between these two features? The great part is you don't have to click on them. You can just query it using standard SQL query language. The other cool thing is you can build custom functions that are implemented at the database level. So in SQL Server, that's your CLR functions, .NET functions that you can write straight in .NET. In Oracle, that's Java. Unfortunately for Oracle, you have to be on something beyond Express Edition because Java is not supported in Express. So for instance, this is a function in SQL Server that you take a point and you give it a distance and a direction, and it buffers it to a line. Pretty simple. It's just a basic function. You have to have a little tag to the top to expose it to SQL Server. The cool part is that come on, Jim. You can call the whole thing from SQL. So we got this function. I just call a select statement. Select my addresses layer, buffer in this direction, and say I have a table with my current wind direction. I could buffer and have vectors showing by wind direction from each house, say showing the pollution from someone's chimney. You could even put things in your query that differ based on the type, the age of the house, the type of furnace you have. Things like that that just get expressed back to you visually as a layer with simple query language. You can build these in views or views that update at some frequency. Fighting over here. Okay, so why bother with this? A few interesting things come up. You can have your applications consume your spatial business logic without them even knowing about it. So if you want to supply layers that implement business logic based on spatial rules, they can just be expressed as views, and your application doesn't have to know. Reporting. SQL Server reporting services, as of at least 2008 R2, gives you ability to create maps and reports based on native spatial types. You can dump your parcel with all of its features on it in a parcel report that you can hand to a homeowner or whatever else. If you're a utility company, you want to make a staking sheet, you can plant the features on a piece of paper and print it out. And the other cool part is your application doesn't have to have a third-party spatial dependency. So depending on how and where it's used, if you're not using a map, you don't have to worry about the third-party dependencies. So we're going to talk a little bit about just some use cases that I can brainstorm about this. We use some of this stuff with what we do. Our company does basically mobile solutions, and so why would we care about this? The thing is mobile solutions, not everything always maps exactly to an enterprise database. And so we have to do a lot of middle work to make things seamless. And so one place would be triggers. You can validate geometries before they're inserted. Okay, if someone inserted a point next to this line, it has to be within 100 feet, or we reject it. You can catch that via geometry trigger. You can notify people of changes. Say someone changes a spatial attribute on a layer, you can have a database trigger that notifies the world through email. You can update one geometry based on another, sort of like the idea of a network, but maybe a lower level. I have a table that collects GPS points that are being broadcast from my GPS unit just as points, blip, blip, blip. I have a trigger that's sitting there watching this come in and constructing lines out of it in the background of the database. You can do history tracking of geometries. If geometry gets changed, you just keep a history archive table running. All this is just very simple things running in the background that are really simple to build directly in the database. Reporting was another one. Spatial calculations. You could do reporting based on spatial selection. Give me all the stuff in this county. It's all built into just basic SQL queries that run in the background. Mentioned reports with maps earlier. Data mining. You can do pattern analysis. You can easily do queries that include spatial data that sales pattern by region. Again, it's just basic SQL. It's running. You can then feed into reports. SCADA systems, you can mine the data out of them. Batch operations, the most typical one is data imports. If you are regularly importing a large amount of data, it can get really painful to always have to do it through some sort of UI. I'm not a huge fan of the SD command line tools. They're not very quick to use. If I can import it and jam the data directly in the table through SQL, suddenly things get a lot easier, and I can program it very quickly. Clustering. We had a contract where for Colorado Division of Wildlife, they get GPS collar positions for their mountain lions that are running around 89s. They're doing a study of their habits and where they live, and so they need to cluster these positions based on time. We implemented the solution for them entirely in SQL, where you run an algorithm and it actually goes through and it calculates time and spatial dependent clustering of them, creates the cluster center points, and then all of that data is registered through views to SDE, so it's all consumable in our historical data is another one of those, just catching history as it goes by. Aggregate functions, sort of a cool thing. I can just do a select union of parcels on this block, and it returns the polygon that's the whole block. Again, it's all automated and captured for you in the back end, so you don't have to be doing it in ArcMap manually. Calculated values. If you want in your table to have things extracted out, say I insert a new parcel and I want it to automatically populate the distance from the nearest fire station. Again, that's things that I can either put into a view, where I just query my parcels there and have a view that's expressed applications that tells me the distances. It pulls out the lat and long automatically. It's a Boolean. It's just inside of city limits. All these are very simple queries that you can just build into your views. One example I thought of earlier with the generalization case is you could have a very complex polygon layer that you ask it to generalize for you through a view, and it gives you a simplified version of that layer. There's going to be a performance hit there, but if you do it with triggers, you can actually have two geometry columns in your table, one that's complicated, one that's generalized, and a trigger that whenever your high resolution geometry gets updated, it automatically creates a generalized version of it. Live updates. This would be another one if you have a SQL job running in the background that's getting weather data, say wind direction, temperature. You could actually build a model where your data models itself and modifies or changes over time through the views, so your application doesn't have to know the model. It's all just there. It just keeps querying the tables or the views, and things change for it. And data abstraction is the last one. This comes up quite a bit for things that we do. The person in the field wants to collect points, but they actually wanted his lines in the office, and someone else doesn't care. They just want to know the speed at which those 2 points were traversed. It's great because you can actually pump the data in whatever format you want, and through views and standard SQL, return exactly what each application wants, and again, you just register those with SDE or whatever. So we have an application for pipelines that all they really care about is the begin and end point of the line, but in ArcMap they want to visualize it as a line. And so the field user actually goes out and they collect the start point of something on a line, like a new pipeline segment. They'll collect the start. In the end, when they get up to the office, it open up in ArcMap, it shows up as a line. It's stored as points underneath. It's just through dynamic views express the user however you want. And you can extend that as far as you want. There's all sorts of